To remove or not to remove the thermostat? That is the question. Now, this is a common topic of sometimes heated discussion. You have one side saying it's okay to remove the thermostat, primarily arguing that it is only needed if you are located in an area that experiences winter, and you have the other saying not to remove it because the engineers designed it that way, so it's there for a purpose. In order for us to answer that question much better, it is imperative that we understand what this is for and why it was first introduced in an engine. So we will talk about everything as to when and why a thermostat was introduced in an engine, the difference between a gas and diesel engine, how the thermostat works in relation to the cooling system, the clutch fan, the antifreeze coolant, old vehicles versus newer vehicles, why people choose to remove the thermostat, and is it okay to do so? So bear with me because I will try to make this as comprehensive as possible, okay? So as we all know, as the engine runs, it gets hot, hence the need to cool it down with water or coolant to prevent it from overheating. Now, in the advent of the automobile era, during the late 1800s to the early 1900s, the more common type of engine on a vehicle back then was a petrol or gasoline engine. Diesel engines back then was too cumbersome, was too large, and was primarily only used as power stations or at factories. So somewhere before the 1920s, they discovered that while engine cooling is needed to prevent overheating, too cold or low temperature isn't also good, as it has the tendency to result to premature wear and tear, because gasoline only burns when it is vaporized, meaning when it has already transformed from liquid into gas. And the problem with gasoline is it is very reactant to temperature. The colder the temperature, the lesser it vaporizes. And if it doesn't vaporize, it won't burn efficiently. In fact, it was discovered that at a temperature of 15 degrees Celsius, gasoline only vaporizes at 50%. Meaning, if you introduce this much gasoline, just for example, okay, if you introduce this much gasoline, only half of this vaporizes and burns, and the other half condenses inside the cylinder. And you don't want that, because not only would that be wasteful, because you're only burning 50% of the fuel, the other 50% is not only wasted, but leads to premature wear and tear of your engine. Because as I've already discussed in this video, and I invite you to watch this one after, gasoline has no lubricating quality. In fact, it can even serve as a solvent. That is why you would even see people using gasoline to clean and degrease parts, because this is actually a very good degreaser. So like I've said, if gasoline does not vaporize, not only will you not have good combustion, but also the remaining gasoline will act as a solvent inside your cylinder. So while you have your oil trying to lubricate the cylinder as well as your piston from down the crankcase, you have a wet flow of gasoline here serving as a solvent or degreaser, removing that lubrication, resulting to wear and tear. And not only that, this is also the reason why sludge tends to form in your engine oil. And if you have noticed, it's more common for a gas engine to have a longer cranking startup, especially during cold mornings. And this is also the reason why the exhaust smells of gasoline, because some of that gasoline isn't burned properly. And it is only after a few minutes when the engine has warmed up and that smell goes away. Because like I've said, gasoline doesn't readily vaporize when it's cold. And this is where the old practice came in that you heard from your father or grandfather or old-timers of letting the engine warm up first for a few minutes before driving off. Because as gasoline is subjected to heat, it vaporizes much better, hence it burns much quicker, cleaner, and the engine becomes more fuel efficient. So, like I've discussed earlier, gasoline needs to vaporize in order to burn. Diesel does not vaporize. You only need to make sure that it is atomized into small particles, just like this, in order for it to burn quicker and cleaner. So if gasoline has no lubricating quality, diesel on the other hand is more like oil. That is why you can run diesel engines just on vegetable oil or cooking oil or plainly just oil, because diesel essentially is oil. That is why diesel engine has more the tendency to spew black smoke, because you are essentially burning oil. So if on a gas engine the remaining gasoline, if any, can serve as solvent or degreaser, on a diesel engine the remaining diesel, although you do not want that, but it can still help lubricate your cylinder. Like I've said, diesel essentially is oil. And not only that, diesel engines are equipped with a heater which we commonly refer to as glow plugs. Gas engines don't have this. They have spark plugs. Now, this glow plug serves no other purpose, which is to help a diesel engine start up, especially when cold, like I've already discussed in this video. So even if there's a difference between gas and diesel engines, primarily with the way they burn, there's one thing that they have in common with, and that is they both produce internal combustion. And internal combustion produces a lot of heat. And one of the very first engine component that gets exposed to that heat is the piston itself. And as we all know, metals like aluminum, iron, or steel, when they get exposed to heat, they expand. That is why you would sometimes see mechanics use heat, because as it expands, it will become more loose. So in like manner, as the piston gets exposed to heat, it wants to expand. Let me show you, okay? So say for example, this is your piston. Let's take a measurement here. And it's got a measurement of 90.44. Now should we apply heat on this piston, just on this surface, okay? Let's try to apply heat for 30 seconds. Okay, so let's measure that again. See, it became 90.49. So it already expanded from 90.44 to 90.49, okay, with only 30 seconds of heat. And you do not want that to happen inside your cylinder, because as the piston expands, it's going to push itself up against the cylinder wall. So the piston will expand, pushing up against the cylinder wall, producing a lot of friction, resulting to wear and tear. And maybe the piston could possibly even get stuck inside the cylinder as the piston expands inside the cylinder. So in order to prevent that from happening, regardless if it's gas or diesel, the piston is slightly tapered, just like this. Now, of course, this is just an exaggeration, okay? Just so we can explain it much better. But meaning, the top part is slightly smaller than the bottom part. Let me show you, okay? So ideally, when measuring piston diameter to cylinder wall clearance, you would want to take that measurement here. And preferably, you would want to use a micrometer instead of a caliper. But just so I can show you, we'll just use a digital caliper, okay? The measurement is 91 millimeters, exactly. Here, it's 90.44. 90.45. Previously, it was 90.44. The top part is slightly smaller than the bottom part because, like I've said, it is the top part that gets exposed to heat first and expands. And as it does, it would now look something like this. And that is why we have oil jets here for two reasons. One is, of course, to help lubricate the piston as well as the cylinder. And number two is to help cool the piston down. That is why we also have oil coolers like this one. Now, because the piston has the tendency to expand, that is also the reason why you do not want the cylinder or the engine block to be cold. Because while heat results to expansion, cold results to contraction or the metal slightly shrinking. This is also the reason why you see some manufacturers dip one part into nitrogen to freeze and shrink it, and the other component exposed to heat to expand it, and then they make the two together, and as the two goes back to normal temperature, you now have an interference fit. So like I've said, that is also the reason why you would want the cylinder or the block to heat up as quickly as the piston expands inside it, okay? In order to avoid friction that would result to wear and tear. Hence, they install a thermostat on an engine, regardless if it's gas or diesel. So, as I've said earlier, as the engine runs, we need to cool it down. So, at the heart of our cooling system is the water pump. This water pump is driven via a pulley connected to the crankshaft. On the water pump is where our fan is located as well. Now, for brevity, we will no longer discuss about how it was in the old days with regard to thermosiphon and all that, okay? So let's go back to this, okay? So as the engine turns, the pump turns together with the fan. So this pumps water inside the engine, cooling it down. The water absorbs the heat of the engine and exits through here. And the heated water gets inside a radiator and goes down through it. And these fins, okay, these fins help dissipate the heat. So as the fan draws in cool air from outside, it effectively cools down the radiator as well as the water. So when the water gets through here, it gets sucked by the water pump again, and the cycle repeats itself, okay? And the problem with this design is, like I've said, as soon as you start the engine, it is already being cooled down long before it even gets hot. And the result is, the engine takes a longer time to warm up. And not only that, it results to unstable engine temperature, meaning the temperature of your engine will tend to go up and down based upon two factors. It will depend upon the weather condition, whether it's hot or cold, and depending upon driving condition, whether the vehicle is running or idle. When the vehicle is running, the temperature of your engine is cooler because there is more flow coming into the radiator. And when you are at a standstill, the temperature tends to rise because there is less flow of air going through the radiator to cool it down. And that uneven or unstable temperature is exacerbated depending, like I've said, on weather conditions. Now, it's not so much a problem when the weather is hot, but when the weather is cold, especially winter cold, and like I've said earlier, steel, when it is exposed to cold, it contracts or shrinks. In fact, let me show you, okay? I took a measurement of the cylinder at an ambient temperature of 30 degrees Celsius is at 91.10 millimeters. This was at 12 noon. I took another measurement at 9 p.m. with a temperature of 27 degrees Celsius, still the same, 91.10. At 5 in the morning with a temperature of 25 degrees Celsius, still the same 91.10. However, I placed this inside the ref for 8 hours with a temperature between 6 to 10 degrees Celsius, and the measurement went down by 0.01 or 91.09. I again placed it inside the freezer for 8 hours. The measurement went down to 91.06. Now, you might think that a difference of 0.04 is not much, but you should know that the ideal cylinder to piston wall clearance is only between 0.02 to 0.04 mm. Now, if the cylinder shrinks even by 0.04 mm, that means the clearance is gone. And as I've discussed earlier, that is why you want the engine to warm up quickly in order for the cylinder to expand as the piston expands inside it. Otherwise, if the temperature of your cylinder is cold, it will shrink and contract, and the piston wants to expand, and that would result to friction, resulting to wear and tear. So, as I've shown earlier, metal shrinks when it is freezing cold, and water freezes and turns into ice as well. Nowadays, we already have coolant, but before, the cooling medium was just plain water. And like I've said, water freezes and turns into ice, and we do not want that for two reasons. One is, if this has turned into ice, you won't have circulation, thereby causing the engine to warm up even longer because it is surrounded by ice. And two, although metal shrinks when it is freezing cold, liquid on the other hand tends to expand when it turns into ice. It expands up to 9%. That is why if you put a bottle of soda or beer in the freezer, it would burst open when it freezes. People think it's because of the composition of the beer or soda, but it's not, because it expands when it freezes. Even this bottle of water, if we put this inside the freezer, we would see this bubble up if the water inside it freezes. You see? So you don't want that to happen inside your engine, because maybe your engine won't burst like a bottle of soda, but it will create leaks, especially through the seals. So not only will you not have circulation, you might also have leaks. That is why before the advent of the antifreeze coolant, people just use water, and come winter time, they would just add and mix a solution of antifreeze in order to keep the water from freezing. Now, although a lot of us loosely refer to this simply as thermostat, let it be known that the word thermostat is a general term, okay, which refers to a regulatory device designed to operate depending upon the temperature. Because this is a thermostat, this is also a thermostat. Whenever you're adjusting this on your AC or this on your oven, you are basically adjusting the thermostat. And there are all kinds of thermostat. There are adjustable thermostats like this one, and this is a preset thermostat. This is a thermostatic switch which turns on and off depending upon the temperature you adjusted it to. This is the one that I have on this vehicle, and this is a thermostatic relay which more or less works the same as this, only this is electronic. And this is a type of thermostatic valve intended to open and close at a preset or already given temperature. So if a thermometer like this one, or this one tells us the temperature, the thermostat on the other hand doesn't necessarily tell us the temperature, but rather is designed to operate at a given temperature intended to regulate something. So we are talking about this guy, an engine thermostatic valve. So, because this type of cooling system produces uneven or unstable engine temperature, That is why a thermostat is installed in order to maintain a temperature regardless of whatever conditions. As you can see, even on this manual, it says the cooling system is designed to keep every part of the engine at appropriate temperature in whatever condition the engine may be operated, which, like I've said, is dependent upon two factors, which is one, depending upon the weather condition, if it's hot or cold, and two, the driving condition, whether you are running or idling. So this has two functions. First is to help the engine warm up quickly, and second is to help maintain it at that particular temperature. So this is designed to begin to open at 82 degrees Celsius plus or minus 1.5 degrees Celsius and fully open at 95 degrees Celsius. So let's put a thermostat here, okay? Illustrated by this stick. So with the thermostat there, that would now prevent circulation of the coolant because this is closed. But the problem with this is, one, it would result to uneven cooling or hot spots because there is no circulation, meaning it will heat up here first because this is where most of the initial combustion takes place. So it will take some time before the heat will radiate to here, here, and eventually to the thermostat before this begins to open to allow circulation of coolant. And number two problem is it could also cause leaks because you have this blocking the circulation. The pump is already turning, wanting to circulate that water, but because you have this, okay, that closes the system, so that pressure is going to want to escape, and more often than not, it would leak through the seals. So in order to prevent hot spot and leakage, we need to incorporate a bypass. And so this is our bypass. Now if we look closely, we now have two outlet points, one here and one here, and two inlet points, one here and one here. So when the engine is cold, the thermostat is closed, okay, and prevents circulation of coolant from here to here. But it allows circulation from here to here, you see, because this is open. And this is what we see on this engine. It goes out here and enters the pump through here. See that? So, as the engine runs, it will warm up much faster because it is only circulating through here, bypassing the radiator. See that? And when the temperature reaches 82 degrees Celsius, this will now begin to open, allowing cool water or coolant to enter the system. So you will now have a mixture of cool water and hot water circulating within the system. But should the temperature reaches 95 or hotter than 95 degrees Celsius, this will now fully open, and in so doing, it will prevent the circulation through the bypass, allowing all the circulation only through the radiator to help cool it back down. So this is why we call this a double thermostatic valve, because we have one valve here and one valve here. One valve here and one valve here. So that is basically how a thermostat is able to maintain the temperature regardless of whatever conditions. Like I've said, regardless of the weather condition, whether if it's hot or cold, and two, regardless of driving condition, whether the engine or the vehicle is idle or running. Now, in order to help the thermostat maintain a temperature between 82 degrees Celsius to 95 degrees Celsius, that is why they replaced this fan with a clutch fan. In the old days, it's just a simple fan with a shaft attached to the pump, the water pump. So the fan rotates at the same speed the pump is turning. Nowadays, we have a clutch fan. And this fan is designed to sleep or freewheel when it's cold, meaning it will not spin at the same speed the pump is turning. Now, this also reacts to temperature. That is why this is made of aluminum. So when the engine is cold, the radiator is cold, and the fan is just going to sleep, drawing less air from outside, helping the engine to warm up much faster. But, like I've said earlier, should the temperature becomes too hot, the thermostat will close the bypass, circulating all the coolant into the radiator, and as the fan draws in air, the heat from the radiator will affect the clutch fan, gripping the shaft much harder so that it will spin much faster or as fast as the pump is spinning as well. And so that is why it is called a clutch fan, because it grips or it clutches. Also, like the thermostat, depending upon the temperature. So anyway, are you still there? I hope you're not bored. We are almost done, okay? Now, older vehicles are pretty much simple. Of course, you already have a thermostat and a clutch fan, and basically you just have this, a temperature sensor that tells you the temperature of the engine. Now, newer vehicles, especially with EFI engines, EFI meaning electronic fuel injection, are more complicated. Now, if you're wondering if you have an EFI engine, generally okay, if you see this, a wiring harness attached to the injector, if you see a bunch of wires attached to the injector, that is a telltale sign of an EFI engine. And if it's an EFI engine, then there is an ECU somewhere. Engine Control Unit, or what most of us colloquially refer to as a computer box. And it is more often than not located somewhere behind this. If we remove this, we can see that computer box here. And if it's got a computer box or ECU, there's a bunch of sensors attached to it. And unlike older vehicles without a computer box like this one, you only have the ECT or engine coolant temperature sensor. Newer vehicles, not only do you have the ECT or engine coolant temperature sensor, but you also have the IAT or intake air temperature sensor and fuel temperature sensor. Some engines, they have temp sensors for the exhaust as well and more. But anyway, all these sensors are sent to the ECU, and this computer box is designed and programmed to operate with the aim of maximizing fuel efficiency without sacrificing performance. In the old days, we just have a temperature gauge intended to inform us of the temperature of the engine. Now, the most common reason why people choose to remove the thermostat is to avoid overheating problems. Because this little thing, when this fails to function, can destroy your engine. Because the problem with this is that when it fails, it almost always fails in the close position, in this position. You see, this is constantly under spring tension. When it opens, the spring is already trying to push it close again. And the problem is, if this no longer works, this will never open, leading to an engine overheat. And let's face it, when we are driving, we don't always pay attention to this. And at times, it's already too late that we notice the temperature is already all the way up, that the engine is already overheating or has already overheated. So my suggestion is, at the off chance that there are any car manufacturers watching, if this isn't still a thing, is that to include a warning, a flashing light, or say an audible warning, for example, that sounds an alarm in the event that the temperature begins to go beyond and above its normal operating temperature. that an engine overheat is about to take place so that the driver will be informed and pull over as quickly as possible in order to avoid a total engine overheat that could lead to the destruction of the engine. The answer is yes and also no. To some extent, those who are saying that it is only generally needed in areas that experiences winter are correct. As I've explained earlier, metal contracts or shrinks when it is subjected to freezing cold temperature. But then again, to some extent, those who are saying that the engineers designed it that way, so it's there for a purpose, are also correct, especially with EFI engines or engines with a computer box. It all depends, I suppose, as to where you are located and as to what type of engine it is. As you can see, I have two vehicles here. They are both 2.5 diesel engines. This one's got a thermostat and this doesn't. This one, ever since before, and even after I rebuilt this engine back in January of 2020, I never bothered to include a thermostat because generally, as far as I'm concerned, I find that it is not necessary because I live in an area wherein the ambient temperature only ranges between 24-25 degrees Celsius to 30 to 35 degrees Celsius. Now, would I consider putting this back on there? Maybe. Only if the ambient temperature goes lower than 15 to 10 degrees Celsius or lower. Or maybe if I live in Baguio City, then I would consider installing this. Now on this engine, regardless of where I'm located, regardless of the ambient temperature, if something goes wrong with it, I would not remove and condemn this, but I would simply replace it. Why? Because this is an EFI engine that is controlled by an ECU that runs the engine depending upon the signals sent by the sensors like IAT, intake air temperature sensor, ECT sensor, and fuel temperature sensor. If you remove this, your engine will never reach operating temperature that the ECU is designed and programmed to operate at. And if that happens, an example of which is from this manual outlining the IAT sensor, intake air temperature sensor. Based on this signal, the ECM increases the fuel injection volume to improve the drivability during cold engine operation. So if your engine never reaches operating temperature because you remove this, the ECU is going to assume that the engine is still at its warm-up stage and increases the fuel injection volume, and you end up with less fuel economy. So that is why, like I've said, on an engine like this one, regardless of where I'm located, if I experience winter or not, I would not consider removing the thermostat. Now, on a gas engine, as far as I'm concerned, whether it's an old engine or newer EFI engine or GDI, gas direct injection engine, regardless of whether I experience winter or not, I think it's more beneficial to have a thermostat because, like I've discussed at the very beginning of this video, gasoline is very reactant to temperature. The colder the temperature, the less it vaporizes. And in like manner, the hotter the temperature, the more it vaporizes and burns more efficiently. Now, before I will end this video, I would just like to say this, okay? I'm not telling you to remove or not to remove the thermostat. If you do not want to remove the thermostat, or you want to remove it, or have already removed it, or for whatever reasons it is you may have, it's up to you. The choice is yours. It's your engine, your prerogative, your money, and if you're going to have problems with your engine, then guess what? It's going to be your problems as well. So I do believe that's it. I hope you're not bored. I'm sorry if this video is long, but I feel that it is all necessary to fully explain this topic. One cannot just simply say it's okay to remove it or not to remove it without explaining all that I have discussed. So if you like this video and want to learn more, I invite you to click on this This is a comprehensive video on the differences between a gas and diesel engine. You can click on this if you want to learn about the EGR, and this if you want to learn about the PCV. So I do believe that's it. I hope you found this video helpful and informative. If you do, let me know in the comments below. Like, share, and if you're new to my channel, subscribe if you want to. Only if you want to, and as always, thank you for watching.